All right, welcome. This is actually a continuation of question uh, on Monday. So this is week 12's homework solution. This is Monday, but I'm only going to be covering question 4 and 5. There's two parts to Monday's homework. Okay, the first video was just long, so the second part is just going to cover question 4 and 5. Okay, all right. Explain why question 3 is a function. All right, we know based on a function that for the rule of a function, so let's look at the rule of a function. The rule of the function states that every x, or you could say every single input, which is x, has exactly one output, which is your y. Okay? So, if we plug in a 2 here for your input, if we plug in a -2, we get the output of -11. That's fine. If we plug in a 0, we get the output of -3. That works. If we plug in 2, we get the output of 5. That's great. We plug in a 6, we get the output of 21. That works. Okay? And if we plug in an 8, we get the output of 29. Okay? Nothing breaks here. So, we would say it is a function because every input value, every input has exactly one output. Okay? One output. There you go. Okay? It only does not if we have this, if we also have like 0 and it becomes like, let's say 4, then it does not be, then this becomes not a function, but we don't have that, so it's still a function. Okay, all right, so enter a missing value into the table to show that the relationship is not a function. Okay, remember, a function by definition is when every single input has exactly one output. So let me just paste that and we could just plug in some numbers. So every single input and the value of the input that we're going to plug in here is 1. Okay? What is the output? Has exactly one output, and the output is what? The output here is 0. Okay? So every input of 1 has an output of 0. Good? That works. All right? Then if we plug in 2, we are going to get the output of 2. Okay? Then what happens? Okay? Now, we want it to not be a function, so we have to break this rule. When do we get an output of 0? Okay? Alright? An output of 0, if we plug in 0 here, and if we plug in a 1, this works. Okay? It's only when we change it to be, let's say, 4. Right? Okay? If I plug in a 4 here, this doesn't work. Is the input of 4 have an output of 0? No, because look, here, what was the output here? The output here was a 2. Okay, has an output. There was one output of 0. When you plug in a 1, you get an output of 0. When you plug in the 2, you get the output is 2. If you plug in a 4, you get an output of 0. Wait, but if you plug in a 4, you get an output of 2. Do you see here? This is what happens when it starts breaking. This is when it starts breaking. Okay? This is when it starts breaking. So the fact that we enter a 4 here, it makes it not a function. You could enter any other value. You could also enter in the value of 5. Oh, if we enter in a 5, it works because you see 5 does become 0. So we couldn't enter in 5. Could we enter in a 1? No, it still works. If we enter a 2, it breaks because 2 input will get you the output of 2. The input of 2 will always get you the output of 2, but it says 0 here. That's why this one becomes not a function. Okay, so you could either enter the value of 2 or you could enter in the value of 4, and it breaks this, therefore making this table not a function. Okay, so there you go. This was your solution just for 4 and 5, explaining what is not a function. The previous one went over 1 and 3. Okay.